In exercise 9.2, we're going to start to calculate the distance between places on the Earth's surface. But it's fairly restricted in that we can only calculate the distance between places that both coincide on a great circle. So just to revise or recap, a great circle, the only one we have in this direction is the equator. So we can only find the distances between two places on the equator. If we were up here on a different latitude, we're not on a great circle, we can't use this formula. So it's not a great circle. Oh, sorry. So, yes, we can find distances on the equator between two places, and we do this by thinking about a circle. The equator is this imaginary circle. So as you can see, we're going to be investigating a circle and how you get the distance either all around a circle or between two bits on the circle. And remember, your circle could be drawn in this direction. So I might be talking about the distance from here right around to here, or in this case, I might be just talking about the distance from here to here. The other situation where we're going to apply this rule for finding distances are on these great circles. Now, they're our lines of longitude, and we know that continues around the back and there's a similar imaginary line. So we can, again, use the idea about getting the part of a circle, the distance on part of a circle, and use that to represent the distance between two places. So our circles could also be in this direction, where we're finding the distance, say, between there or there. Now, we're imagining that all of these are circles, and we know that if we calculate the distance all the way around a circle, we use the formula for circumference, which is 2 pi r. So if we're on the equator and we want to know all the way back to that point on the equator, gone all the way around and we're coming back to that point, we can use 2 times pi times r, where r is the radius of the Earth. If we're looking at a position here and we're going to go down through the South Pole, round the back and up through the North Pole back to this position, to find the distance that would be, we could also use 2 pi r, where again the radius is the radius of the Earth. When we don't want to go the complete trip around the Earth, then we might just want to find between two places. So either think of it like going from the equator down to a place, or think of the equator drawn in this format. Then we're going from this place around to this place, or we're on a great circle and maybe we're going between two places down here. Now, if you're only doing part of the entire revolution, then you have to know your angle. So this is really important, the fact that we've got that angle here. So we would have to know likewise the angle coming out from the middle, or we would have to know the angle formed in the middle. So you can see there are sort of 3 variations to how your diagram can look, and obviously we need to know the angle formed at the centre of our imaginary circle. The length of, or the distance between these two places, so the length of this arc is the same as the distance between 2 points on the Earth, or on the great circle. So it does only work on a great circle. It's calculated using the arc length of a circle formula, which you've come across before and is on the formula sheet. So be aware of that. So the length, or now we're going to call it distance, is theta, the angle at the centre, or the angle at the centre here, or the angle there, on 360, because it makes that fraction of a circle, times the total distance around, which is 2 pi r. So there are two things you need: the angle at the centre between the two places and the radius of the Earth. So we've got great circle distance is theta on 360, 2 pi r. Please make a note of that.